There are 5 main purposes for us in doing this fieldwork. Number 1 is to learn the principle of running a closed field traverse. Number 2, to enhance students' knowledge in traversing procedure. Number 3, to enable students to get hands-on experience in setting up and working with the total station as well as other instruments for traversing, and collect the data of the relevant fieldwork. Number 4, to allow the students to learn the correct method in doing traversing. And last but not least, to enable students to identify the error and make adjustment to the data if there's an error present by using the correct formula. There are 7 types of instrument which are used in this fieldwork. Number 1, and the most important, is total station. Number 2 is the prism. Number 3, tripod stand for the total station and the prism. Number 4, the compass. Number 5, the wooden pegs. Number 6, the hammer. And number 7, the nails.
Station points of A, B, C, D, E, F were set as a closed boundary by using pegs. Firstly, the total station was set up at A, and it was then directed to the prism at B for the foresight reading of line AB. The horizontal angle HA and horizontal distance HD were taken and jolted down in the field book. Next, the total station was then rotated in clockwise direction to the prism at F for the backside reading of line FA. This time, the horizontal angle HA was set to 0 degrees, and only the horizontal distance HD was taken and jolted down in the field book. After the reading of both fore-bearing and back-bearing at station A were taken, the instrument was then shifted to station B. Steps 2 and 3 were repeated. The total station was directed to prism at C for the fore-bearing reading of line BC. Horizontal angle and horizontal distance were jolted down in the field book. Next, the total station was then rotated in clockwise direction towards prism at A for the back-bearing reading of line AB. Since it was back-bearing reading, the horizontal angle was set to 0 degrees, and the horizontal distance was taken. The instrument was then shifted to station C. Just like the previous steps, the total station was directed to D, and the foresight of line CD was taken where the horizontal angle and horizontal distance were measured. Then, it was rotated in clockwise direction towards B for the backside reading of line BC. Only horizontal distance was recorded and the horizontal angle was set to 0 degrees. The instrument was then shifted to station D. The total station was directed to E, and the fore-bearing reading of line DE was taken, which was the horizontal angle and horizontal distance. Then, it was rotated in clockwise direction towards C, and the back-bearing reading of line CD, where horizontal angle was set to 0 degrees and horizontal distance was taken. The instrument was then shifted to station E. The fore-bearing reading of line EF and back-bearing reading of line DE were taken and jolted down in the field book. Finally, the instrument was shifted to station F. Foresight of line FA, where horizontal angle and horizontal distance were written down, and backside of line EF were taken.
Data collection for closed traverse. First, the fore-bearing and the back-bearing. From station A, the fore-bearing for line AB is 140 degree and the back-bearing for line FA is 39 degree and 30 minute. For station B, the fore-bearing for line BC is 108 degree and the back-bearing for line AB is 327 degree. For station C, the forebearing for line CD is 24 degree and 30 minutes, and the back bearing for line BC is 288 degree. For station D, the forebearing for line DE is 43 degree and 30 minutes, and the back bearing for line CD is 254 degree and 30 minutes. For station E, the forebearing for line EF is 312 degree and 30 minutes, and the back bearing for line DE is 223 degree and 30 minutes. For station F, the forebearing for line FA is 219 degree and 30 minutes, and the back bearing for line EF is 132 degree and 30 minutes. Second, the length for line AB is 88 meter. For line BC is 102 meter. Line CD is 115 meter. Line DE is 123 meter. Line EF is 96 meter, and line FA is 107 meter. Third, included angle. Angle A equal to back bearing AB minus forebearing FA, we get 107 degree and 30 minutes. Angle B, back bearing BC minus forebearing AB, we get 141 degree. Angle C, back bearing CD minus forebearing BC, we get 146 degree and 30 minutes. Angle D, back bearing DE minus forebearing CD, we get 149 degree. Angle E, back bearing EF minus forebearing DE, we get 89 degree. Angle F, back bearing FA minus forebearing EF, we get negative 270 degree, but since the negative 270 degree is actually an angle, so we must plus 360 degrees, so the included angle for angle F is 87 degree. Lastly, the checking for error in data. We calculate the sum of included angle, which is angle A plus angle B plus angle C plus angle D plus angle E and plus angle F. So we get 720 degree. Next, we calculate the actual included angle with the formula 2n minus 4 times 90 degree, where n is the number of stations. Thus, we get 720 degree. So the error is 720 degree minus 720 degree. So we get 0 degree for the error.
Next is discussion. From this fieldwork, we learn to conduct a close traverse survey by using the total station and several formula that has been taught during survey classes. Throughout this fieldwork, we are able to apply technique and knowledge that has been taught. For this fieldwork, one of the challenges that we face is hard for us to setting up the total station, as the horizontal bubble are too sensitive, and it takes quite of our time to just setting up the instrument before we do some reading of the angle. But over time, we get hang of it after several times doing the setting up repetitively, and the time to setting up our instrument are reduced. Theoretically, at the end of the process, the total angle should be 720 degree if the points consists of 6 in numbers. Since the total sum of the included angle are 720 degree, meaning that there is no error during the fieldwork. So there won't be any calculation be done for corrected angle. In overall, there haven't been much difficulties occur during this fieldwork. Only that improvement can be made in decreasing the time for setting up the instrument a little bit more. In doing so, the pace of doing this kind of fieldwork again in the future will become a lot faster. For the conclusion, in a nutshell, this is our second fieldwork for traverse surveying, as we are required to carry out a close traverse. One of the special characteristics of close traverse is it starts and ends at the same point. forming a closed geometric figure called polygon. We conducted the field work together and contribute the task accordingly. Using total station for traverse surveying is a lot more convenient compared to the traditional theodolite, since all the data needed is displayed on the operation panel monitor. The vertical angle, the horizontal angle, and the distance between the total station and the checkpoint are also displayed, as long as the lens targeting directly into the prism, which are on the other side of the checkpoint, which make our work a lot easier and faster, even though there have been some delay on setting up the instrument. Luckily, we are able to obtain data accurately, as our total sum of included angle are exactly 720 degrees. Therefore, it saves our time on identifying any error and do adjustment for angle correction. Overall, it's a great experience for us. We know the proper method in doing traversing, learn the principle on running a closed field traverse, get hands-on experience in setting up and working with the total station, as well as other instruments for traversing and collecting the data of the relevant fieldwork, and also identifying error during our fieldwork. In short of all, the main objective in this fieldwork is achieved. We gain a lot of knowledge about traverse survey specifically, which are a great contribution for us in the future of becoming a survey engineer.